In this video, we will use sines of 18 and 15 to find out sine 3 degrees. The methods used would be similar to how we break up 45 degrees to find out sines of 15 degrees. So you can skip that part if you want. But in the end, we will use Excel to evaluate sine 3. If you're not familiar with Excel, it's a good idea to watch this video. So we've seen again and again the use of this combination formula in the reverse direction. The outcome is known, so is one component. The unknown component is colored yellow to distinguish. Because we will use this relationship often to find out the unknown component, hence it's better to make a formula of the unknown in terms of the known. Let's call these combined angles C. Let's move sine B to one side, cosine to the other. This way, we can square both sides to make use of the relationship between sine and cosine. Expand the left equals to sine C squared minus 2 times sine C cosine A sine B plus cosine A squared sine B squared equals to the right side sine A squared cosine B squared. Cosine B squared is 1 minus sine B squared. Multiply the terms. Now let's move them to the left. So we have sine B squared minus 2 sine C cosine A sine B plus sine C squared minus sine A squared equals to 0. There are so many symbols here. Fortunately, we color the unknown, so it's easy to keep track of what we're looking for. Now we can use the formula for the quadratic equation. All we need is to match a few constants. A is 1, B is minus 2 times sine C cosine A, C is sine C squared minus sine A squared. Using this formula, we know that sine B is 4 times sine C squared cosine A squared minus 4 times sine C squared subtracted sine A squared divided over 4. Take square root of that, plus or minus, then subtract minus 2 times sine C cosine A over 2. These constants can be crossed out. We end up with this formula for sine B. Once the formula is ready, we can actualize these numbers. A is 15 degrees, B is 3, C is 18. All these are known. You just plug them into the formula. Now the question is, should we keep simplifying or stop here? People in the Middle Ages love to simplify because they didn't have a choice. They didn't have a calculator or a computer. That's why they will have to keep going, expand the terms, hoping that some of these terms will cancel out or similar terms can be aggregated in order to get a simpler term in the end. So this is the original term we have. This is the simplified version after a lot of work. It's slightly better, but not as good as we expected. The reason is because of this square root. It's an operation, not a number. 3 is a number. Square root of 3 is the outcome you get after operating on 3, but you don't know what it is. So how to calculate it then? The simplest method is try and error. That's the numerical method. There is nothing mysterious. You try with different numbers, square them, and then see if it's 3. Keep going until they match. You can imagine how tedious this method would get. Fortunately, we have calculators and computers to help us. So next, we will use Excel to determine what this sine 3 is. Open up Excel. Let's name the tab sine 3. Let's copy the formulas for reference. Note that we don't have to carry out the tedious algebra. We can use this formula to calculate sine 3 directly. All we need are the 4 components. If you're using a simple calculator, you will have to calculate each component, get the result, and write down the result for later use. The nice thing with a computer software like Excel is you can store those intermediate results easily, and later you can link them together. Let's type sin18 first. This is the name to remind us what it is. Equals to square root of 5 minus 1 over 4. So SQRT is the Excel formula to take square root. The input number is hosted inside the bracket. You need a parenthesis here. Then we need to square it. You just do it here. Equals to, click on cell B1. It uses the result of sin18 calculation. Then type het 2. This het means raised to the power. So you see how easy it is to use intermediate results. If you're using a simple calculator, you will have to write down this number first, and then input to the calculator for another round of calculations. Then cosine 18 equals to 1/4 times square root, add a bracket. Then inside, type 10 plus 2 times square root of 5, add the parenthesis. Then sin15 equals to square root of 6 over 4 minus 1 over square root of 8. Square of it equals to b4 raised to the power of 2. Finally, cosine 15 equals to square root of 2 plus square root of 3. Add the braces over 2. Square of that equals to b5 raised to the power of 2. Okay, now sin3 equals to, according to this big formula, square root of sin18 squared times cosine 15 squared minus sin18 squared plus sin15 squared, then plus sin18 times cosine 15. Note that it is 0.54, so we should pick the minus 1. Cosine 3 is 1 minus sin3 squared, then take square root of that. Let's compare it to the Excel sine formula. Equals to sine. But note that Excel doesn't use degrees, it uses radians. Radians is the arc length of a unit circle facing the angle. So for 3 degrees, the overall circumference of the circle is 2 pi. So the arc length facing 3 degrees is 3 over 360 degrees times 2 pi. Hence, sin3 using Excel formula is sine 3 over 360 degrees times 2 times pi. So this is the Excel result for sin3. Notice that it's the same as what we got here. Excel formula for cosine is cosine the radians. Again, they are almost the same. Now sines of 3 degrees are known. Next, we will see how to calculate sines for 1 degree.